Hello everyone, myself Dr. Vipul M. Patel from Dr. Subhash Technical Campus. We are meeting here again for the new topic of products and technology. In today's session, we are discussing about chapter number 1, chip formation, definition of speed, feed, depth of cut, and chip breakers. So first of all, in the first slide you can see definition of the speed, feed and depth of cut. So in general purpose, these three terms are very much important in the different manufacturing processes. So you have to understand these things, what is the meaning of speed, feed and depth of cut. So first of all, we are discussing speed. The cutting speed is defined as the surface rate of travel of the cutting edge relative to the workpiece. Now try to understand what is the difference between speed and feed. Feed is defined as the rate of which the cutting tool advances along or into the surface of the workpiece. So how can we define the speed and feed? Try to understand. Speed is defined as the surface rate of the travel of the cutting edge of the tool relative to the workpiece. And feed is defined as the rate at which the cutting tool advances along or into the surface of the workpiece. Now, depth of cut. Depth of cut is the normal distance from the original surface to the surface being exposed by the tool. We can see that if we are using a single point cutting tool in the lathe machine, then how much diameter we want to decrease the workpiece of the workpiece. Then it is called the normal distance from the original surface, or we can say that material or surface of the raw material. Original surface to the surface being exposed by the cutting tool. It is called depth of cut. Now it is the cutting parameters and material removal rate and power required. It may ask in your examination many times. As an example, it may ask in GTU final examination also. So how can we find the material removal rate and power required? So it can be calculated from the speed, feed and depth of cut that we have already discussed. So material removal rate is equal to 1000 FDV mm cube per second, where F we can say it is a feed, D is a depth of cut and V is a velocity, or we can say cutting velocity. So with the use of this formula, we can easily find the material removal rate. If we can find the cutting velocity, then with the use of this feed and depth of cut, we can easily find the material removal rate. Now power required, it is 1000 FDV U divided by efficiency watt. So U is it unit power efficiency of the transmission machine motor. So with the use of this formula, we can easily understand and we can easily find the power required, right? Now important topic is types of chips, chip formation. So how many types of chips are there if we are removing some material or metal from the workpiece with the use of the different metal cutting? Then which type of chip will produce during each and every different operations on the different metal cutting or different with the use of the different material? And mainly there are three types of chips. We can say discontinuous chips, it is also called as a segmental chips, continuous chips and continuous chip with built up edge. So the chip produced during the machining can be broadly classified into the three categories, we can say. And the figure also given in this slide, you can see the figure. With the use of this, you can easily understand. This is called continuous chips. Second one, it is a discontinuous chips, which is also called segmental chips. Third figure is continuous chips with built up edge. So chips with built up edge. Now try to understand the chip formation of these three categories. First one, it is a discontinuous or segmental chips. See, in the discontinuous chips, it is formed by the series of the rupture occurring approximately perpendicular to the tool, plus face each chip element passing off along the tool face. The chip element in the form of small segments, and it may adhere loosely to each other and become slightly longer, right? Since the chips break into the small segments, that's why it is called segmental chips also. Since the chips break up into the small segments, the friction between the tool and the chips reduce, resulting in better surface finishing. These chips are convenient to collect, handle and dispose of. In the discontinuous chips, it tends to be formed when one or more of the following condition exists. If it is brittle material, cast iron, bronze, etc. Second thing is the chip thickness is large, cutting speed is low, and rectangle is also small. Then this type of discontinuous or segmental chips will produce. Understand? So further advancement of the tool, the process of the metal fracture and production of the chip segmental go on the being repeated, and this is how the discontinuous chips are produced, right? So we can say in another language also, as the tool is advanced forward, the shear plane angle gradually reduces until the value of the compression stress acting on the shear plane, it becomes too low to prevent rupture. As I told you that in the first sentence, discontinuous chips is formed by the series of rupture occurring approximately perpendicular to the tool, right? This is the discontinuous chip. Second one, that is continuous chips. Try to understand with the use of the figure how it produces. Continuous chips are formed by the continuous plastic deformation of the metal without fracture. Try to understand. Continuous chips are produced by the continuous plastic deformation of the metal without fracture in front of the cutting edge of the tool and is formed by the smooth flow of the chip, right? So mild steel and copper are considered to be a most desirable material for these obtaining the continuous chips. Which material? Mild steel and copper. It should be considered to be a most desirable materials to produce the continuous chips, right? The chips often have some thickness throughout, we can say that, and this type of chip is most desirable also since it is a stable cutting, resulting in generally good surface finishing also compared to the discontinuous chips. On the other hand, these chips are difficult to handle and dispose of, and these are the conditions to produce the continuous chips. Which one? First one, it is a ductile material. Second thing is a high cutting speed. Third one, that is a small chip thickness. The angle of the the rectangle in the chip formation, it is very large, and minimum friction of the tool and chip. These are the different conditions that can be exist to produce the continuous chips, right? Now third one, that is a continuous with built up edge. So you can see in the figure what is the main difference between this figure and another two that we have already discussed in the previous both the slide. You can see the figure in between cutting tool and raw material. There are some extra metal you can see in between that. So this is this type of chip is very similar to the continuous chips, we can say that, with the difference that it has a built up edge adjacent to the tool face, and also it is not so smooth. It is obtained by the machining of the ductile material also, which is also same as a continuous chips. In this condition of the high local temperature and extreme pressure in the cutting and high friction in the tool chip interface, it may occur, or we can say it may cause the work material to adhere or weld the cutting edge of this tool, or we can say successive layer of the work material are when added to the built up edge, when this edge becomes larger and unstable, it breaks up and part of it is carried up the face of the tool along with the chip, right? Then while we can say that, another thing, this extra material you can see in the figure, that is like a welding material or metal welded on the nose of the tool. It is called built up edge. The chip is also sufficiently hot and gets oxidized as it becomes of the tool and turns blue in the color also. Last but not least, we can say that it first increase, then decrease, and then again increase. So the built up edge changes its size during the different cutting operations, right? So this is the third one, continuous with built up edge. Now chip breakers, these are the different shape you can see in the slide, different chip breakers. When a strict chip control is very desired, some sort of the chip breaker has to be employed. The following type of chip breakers are commonly used in general different manufacturing processes. First one, you can see the shape of this is a groove type, that's why it is called groove type shaft. Second one, it is a step type, so you can see the step. Third one, that is a secondary rack type, so you can see over here, you can see. Fourth one, that is the clamp type, that is over here. With the use of this clamp, we can easily with this mechanism we can easily break the chips, which is commonly used in the different manufacturing processes, right? These are the mechanisms of formation of the chips. The tool will cut to shear of the metal which is provided by. These are the different conditions, we can easily understand the things. If I want to reduce or remove some metal or material from the workpiece, then it is necessary that the tool is harder than the work metal. Understand? Second thing is the tool is properly shaped so that its edge can be effective in the cutting the metal. Third one, that is the tool is strong enough to resist cutting pressure but keen enough to sever the metal, provided there is movement of the tool relative to the material or vice versa, so as to make the cutting action possible, right? Thank you.